When people think about carrying extra weight, they often picture it like wearing a heavy backpack, a passive mass that you just have to drag around all day. But fat is a living tissue that requires constant upkeep. It isn't just sitting there. It demands a dedicated, continuous blood supply to stay functional. While some fat is stored just beneath the skin, visceral fat wraps deep around your internal organs. This deeper layer is significantly more active, functioning as an endocrine organ in its own right. Because it is so active, it constantly releases hormones and inflammatory signals that change how your organs process energy and regulate blood pressure throughout the body. The danger of obesity isn't the physical pull of gravity, it is the extreme biological lengths your cardiovascular system must go to keep this vast network of extra tissue alive. To keep newly formed adipose tissue oxygenated, your body is forced to construct miles of microscopic new blood vessels. You have to fill those newly built pipelines, which causes your total circulating blood volume to steadily rise. This split view diagram compares a baseline heart to one handling extra capacity. To move new blood, the heart increases resting rate and stroke volume. Even asleep, it remains locked in a high-flow state, running a marathon while sitting still. This physical adaptation effectively forces the heart to maintain a constant state of overwork just to supply the expanding tissue with oxygen. That mechanical strain is quickly compounded by a chemical shift. Those inflammatory signaling molecules secreted by visceral fat flood into your bloodstream. These signals trigger your sympathetic nervous system, instructing your body to aggressively retain sodium and water. In this cross-section diagram, watch the physiological reaction. Blood vessels constrict, turning flexible pathways into narrow, rigid pipes. You are forcing a higher volume of blood through a constricted space, causing the internal pressure of the entire system to skyrocket. High blood pressure is the violent physical collision of an over-cranked pump driving fluid against a collapsing, unyielding pipe system. When the liver is overwhelmed by fatty acids from visceral fat, it stops responding to signals that tell it to store energy. It begins pumping glucose out, even when levels are high, resulting in chronic insulin resistance. When blood sugar stays chronically elevated, those glucose molecules physically scrape and irritate the delicate inner lining of your blood vessels. That smooth inner lining is called the endothelium. As it becomes damaged and inflamed, the body attempts to patch it up with plaque, a process known as atherosclerosis. This degradation slowly chokes off the major arteries supplying the brain and the heart, while simultaneously starving the microscopic capillaries that keep your nerves functioning. The elevated blood sugar actively dismantles the very vascular highway that your overstressed heart is relying on. How exactly does a heart keep beating against high volume, extreme pressure, and narrowing blocked pipes? This cross-section illustrates the adaptation. The left ventricle thickens its muscular wall inward to generate more pushing force, a process called left ventricular hypertrophy. But thicker muscle is stiffer. The wall loses its ability to relax and fill, culminating in diastolic heart failure. Because this entire cascade is driven by active tissue, shrinking that adipose tissue has an immediate therapeutic effect. Dropping just 5 to 10% of your body weight reduces the total blood volume. The inflammatory signals quiet down, and rigid blood vessels dilate. Treating obesity acts as a necessary mechanical rescue mission, alleviating the crushing dual load on the human heart.